Hi, in this video, we are going to look at literal equations with exponents and roots. In our previous videos, we have said that the first thing you need to do when transforming a formula is to determine the operation in the equation and then perform the opposite operation. Now, the opposite operation to a square is a root and vice versa. Please remember that a square has a positive and a negative root. To better explain how we tackle these kind of questions, let's look at some examples. Make the letter in bold the subject in the following equation, and our letter is x. We have x squared, so to get rid of the square, we're going to root. So we put a root around here and a root around the g. Now the root and the square will cancel and we're left with x. And on the right, we have g under a square root. But remember that a root can be positive or negative. So we say positive or negative, the square root of g. Let's do another one. The square root of x is equal to y. To get x by itself, we need to square the square root of x, which means we square y as well. Now, the square and the root will cancel, and we have x is equal to y squared. The square root of x over y is equal to a plus b. The first thing we need to do is we need to get rid of this root over here. So we're going to square this whole term, the square over here, which means we square both a plus b. On the left, the root and the square will cancel, and we have x over y is equal to a plus b squared. Now to get x by itself, we multiply both sides by y. Put y over there and multiply by y over here. On the left, the y will cancel and we have x. And on the right, we have y multiplied by the bracket a plus b squared. Let's do another one. Gx plus r squared is equal to s squared. Now r is our bold term. So the first thing we want to do is get r squared by itself. We want to get this whole term here by itself. We see a plus sign, so we know it's positive. So we can leave r squared where it is. On the right, we have s squared. And we're going to move gx. So we say minus gx. But we don't want r squared. We want r. So we have to square root r squared, which means we square root this whole side of the equation over here. On the left, the square and the root will cancel out, and we're left with r. And on the right, we have s squared minus gx, all under a root. And don't forget your plus and minus signs. Let's do another one. V squared z is equal to w, and v is our bold letter. But we want v by itself. We don't want the z. So let's divide both sides by z. Over z over here, and over z on the right. On the left, the z's will cancel, and we have v squared is equal to w over z. But we still have v squared, and we want v. So to get rid of the square, we square root, which means we square root this side as well. Now the square and the root will cancel, and we're left with v. And on the right, we have w over z, all under a square root, which can be positive or negative. Let's do one more example. C is equal to a squared plus b squared under a square root. Now, in previous examples, we have looked at numerous terms within a bracket, a squared plus b squared in a bracket. And the way that we tackle it is we need to get rid of the bracket first. And this applies to questions like this. Before we can move the a squared away from the b squared, we have to get rid of the root. And to do that, we can square this whole term. Put a square over here. And then we can square the left side, which means we now have c squared is equal to the square and the root cancel out, and we have a squared plus b squared. B is our bold letter, so to get b by itself, it's positive. So let's move the a squared across, and we have c squared minus a squared is equal to b squared. But we don't want b squared. We want b. So to get b by itself, we're going to root b squared, which means we root this side as well. And we're going to have c squared minus a squared, all under a square root, is equal to, on the right, the square and the root cancels, and we're left with b. And b is now the subject of this equation. Please work through some questions in this section before moving on to the next set of videos.